Today we spent much of class looking at the constant rate of change, discussing slope and its characteristics, looking at how to identify or find slope using 2 points, how to identify or find slope within an equation, how to identify or find slope using when you're looking at a graph, and how to identify and find slope when looking at a table. And a lot of these concepts kind of overlap with some things that we've been doing in class previously, which is why it was a good time for us to look at slope, and you'll see a lot of direct application as we continue on through the remainder of the unit. So we're going to look at a couple of problems, and I might work out a few of these problems a bit more than I normally do, just to make sure that you have a good understanding of what takes place in these particular problems. So anytime we have a graph, the points are given to you, the coordinate pairs for each point here. However, the simplest way to do any problem with a graph, as long as you have a clear indication of where it goes through the grid lines, is our rise over run. And we talked about in class how m, which was our slope, is equal to rise over run. And especially while we're in 7th grade, it would be a great habit for you to go ahead and write m equals rise over run for every problem, just to reinforce that into your head until you get really comfortable and really used to it. So we're going to rise from our furthest point on the left up until we reach an equivalent elevation to our next point on the line. So going straight up, since this is on the y-axis, I'm going to continue straight up. Well, it stops right there. That went up 1, 2, 3, 4, 5 units. So my rise is 5. Now from this point, we figure how many units do I have to move to get over to my point on the line? And that would be 1. So we went up 5, we went over 1. So my rise over run is 5 over 1. That fraction can be simplified to 5. So in this particular problem, my slope, m, equals 5. I'm not going to solve number 2, but it seems like a good point to realize that we have 3 points actually that we could work with. One is not labeled, it's 0, 0. So I could find the rise over run from 0, 0 up to 3, 2, or since the line is going to have the same slope no matter what 2 points I use, I could start here at 3 over 2 and go up and then over. Either method makes me a triangle, and it gives me a rise value and a run value that would be equivalent for any set of ordered pairs that falls on this particular line. Number 4, we learned another formula for slope. Aside from understanding it on a graph with rise over run, we used the formula m equals y2 minus y1 over x2 minus x1. And we realized that the y1 refers to the y value from my first point. The y2 refers to the y value from my second point. So I could call this my first point and my second point to help me keep track of which terms I should be using. So now m equals my y2 value. I need to grab the y value from my second point, which is 12, minus the y value from my first point. And be very careful here, because the y value from my first point is negative 4. I'm going to put that in parentheses so that I realize that I have a minus sign because my equation utilizes a subtraction sign. And I have a negative 4 because my y value for my first point is a negative 4. Now this goes on top of my x2, so from my second point, my x value, 2 minus my x1, my x value from my first point. So 12 minus negative 4. Well, anytime we have a minus negative, I can circle them, and that becomes a plus. So now I'm looking at 12 plus 4 is 16. 2 minus 3 is negative 1. And when we simplify 16 divided by negative 1, that simply equals negative 16. So my slope m equals negative 16. Number 7, 8, and 9, we're simply asking for you to be able to identify the slope. And since we're already given an equation in which y equals mx, all we're looking for is that value sitting right in front of x, the coefficient, because that's going to be our m value, which is our slope. So for number 7, the slope is 2/3. For number 8, the slope is negative 3. Now for number 10, I'm not going to do this whole problem for you because we've already done an example that utilizes the slope formula, y2 minus y1 over x2 minus x1. But I want to remind you how to get your ordered pairs. You use your information from your chart. So 1 second for 5 feet is equivalent to 2 seconds for 10 feet. Well, if I graphed both of those on points on a graph, I would end up with a proportional graph. But I also have now a first point and a second point with a x and a y value, which I can very easily plug into my equation, y2 minus y1 over x2 minus x1, and find out my slope from both of those problems, 10 and 11. The backside of this worksheet should have been all review, just trying to keep you refreshed on some of the concepts because Unit 3 kind of extends for a good long time through November and into a good bit of December. And I don't want your breaks to cause you to forget some of these standards, so we're going to see a good bit of review on the reverse side of worksheets as we progress through this unit. So it says to write a proportion for the situation and then solve. So my proportion, my appropriate unit rate when dealing with dollars is to have dollars in the numerator, so $660 over 55 tickets is equal to an unknown number of dollars over 13 tickets. And now we're simply cross-multiplying our proportions. So 660 times 13 is equal to 55x. And I'm going to let you finish solving that problem, and we will discuss it in class if you have further questions. One last problem that I want to review, just to make sure that everyone's on the same page on solving these problems. Distribution was a real struggle on the Unit 2 test, so I figured it was a great idea to bring some of these problems back in for review. Anytime we have a parentheses, that means that we're going to have to do some process of distribution. And our order of operations dictates that we do the parentheses first. So I'm going to do 2 minus negative 5, or minus 5, and I need to distribute that minus 5 into everything in the parentheses first. So negative 5 times x would be negative 5x. Negative 5 times 2 would be minus 10. And don't forget to bring down the 2 because we haven't done anything with it yet. So 2 minus 10, because we're combining like terms. These are both constants. 2 minus 10 is negative 8. Haven't done anything with the minus 5x yet. Equals 7. In order to get x by itself, I need to add 8 to both sides. Negative 8 plus 8 would cancel out the 8. That would make 0. 8 plus 7 is 15, and I'm going to move over just a little bit, make sure I have enough room. So 15 is equal to negative 5x. The next step would be to divide by negative 5. Negative 5 divided by negative 5 is positive 1, so that would leave me with x all by itself. Positive 15 divided by negative 5 is negative 3. So my solution when I solve for x equals negative 3. And if you remember, I told you there would be no reason for anybody missing these types of problems because we can check our answer as easily as we can solve them. 2 minus 5 times our x value from the problem is negative 3 plus 2 equals 7. First thing I need to do is simplify everything in the parentheses. Negative 3 plus 2, negative 1, and now again I can multiply negative 5 times negative 1 because I have to do multiplication before I do addition or subtraction. Negative 5 times negative 1 is positive 5. 2 plus 5 is 7 equals 7. Well, my solution is correct. So I accurately solved for my x value, which was negative 3.